foundation with beam. If you want to design a raft or mat foundation of any structure, firstly you have to analyze the model after giving all loading like dead load, live load, seismic load, and all the combination. And after the analysis, and uh, then you have to start. Then you can start to design the raft or mat foundation with grade beam or rib beam. So firstly, you have to create the uh, mat mesh and connecting all the column by beam, and then you have to design this. So let's start how to design and modeling it. So firstly, you have to view font view and select node cursor and select the support only. So view selected object only and top view. So this is the support point of column, and you have to create a mat mesh which is projecting from more than 1.5 meter or 1.2 meter more wider area from this area. So if to create this area, so you have to copy along z direction, paste along minus z direction 1.5, and this is also copy and paste along 1.5 z direction, and this is along x direction 1.5, and this is also paste along minus 1.5, and this is the area of mat foundation. So before creating mat mesh, you have to connecting uh, all the node to provide the grade beam. So this is the along z direction, geometry, connect, x direction, create, and grade beam along z direction. You have to select this. And select this. So this is the grade beam uh, into the mat. So firstly, create this beam, and after that you have to provide the mesh. This is along the right hand clockwise. Click horizontal mesh, and each division is zero point 0.5 meter. So 1.5 meter length, you have three division. So this is three, this is three, this is also three. Apply, and this is also equals to this area, this area, and this area. So this copy it and paste here, here, and here. So go to select cursor, select, copy, and paste with reference. And this reference point, you have to OK, and click here, OK, click here, OK, and click here, OK, OK. And again, go to geometry and generate mesh, create mesh, and this is create mesh corridor 0.5 division 6. This is 3, this is 6, this is 6, this is 3. Apply. And this area is equal to this, and this. So select plate cursor and copy it and paste reference point this. Okay, and click here. Okay, and click here. Okay, 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 okay. Now we have to create mesh at this area. So again, go to geometry, create mesh, create clockwise direction, quadrilateral, 0.5 division, 3, 6, 3, 6 apply, and this is the area which is same as this. Select, click cursor, and select, copy, paste, reference. Okay, 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 okay. Yes, and this area is same. This. So now also go to geometry, create mesh. This. 3 meter and point 0.5 division. So this is 6. Apply and copy it. So select, people copying. Select this, copy, paste, reference, copy, 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 okay, okay. So the purpose to provide the grade beam. This is the grade beam. The purpose before creating mat mesh, uh, the grade beam provided, because of, if the grade beam is creating after the mat mesh creating, then the grade beam in this point are not divided, not break the, these beams are not breaking if the beam are created before the mat mesh created. So uh, after the mat mesh created, if the grade beam is provided after the creating mat mesh, the beams are not breaking break. So it is also minded, after creating the grade beam, then provide the assign the mat mesh. And after that mat mesh creating, you should have to provide the actually property, and then design the mat mesh. So now the model is already completed. Now here we have to provide properties. Now this is the column and beam properties, and extend perimetric, and the grade beam height should be 650, and width is 500 mm at, and this is assigned. And now thickness of plate mesh 0.5 meter at, and assigned to view. Okay. Now you have to provide the support replacing this support. So you have to delete it and create again, and foundation, mat foundation, Y only. And this is the subgrade modulus, which is the bearing capacity divided by the permissible settlement. The bearing capacity means safe bearing capacity or allowable bearing capacity. Suppose suppose our suppose our safe bearing capacity is 8 ton, 8 ton per meter square. 8 ton means 80 kN, and the formula to find out the subgrade modulus reaction is factor of safety into safe bearing capacity divided permissible settlement. So safe bearing capacity is 80 kN per meter square, and into factor of safety 2 divided permissible settlement means 75 mm. So 75 mm is equal to 0.075. This is the subgrade modulus reaction, 2133.33, and round figure it will be 2133. So this is the vertically subgrade modulus reaction is 2133 at, and this subgrade modulus we have to assign all the plate node are presenting here. So select plate node and select this all the plate and assign. This subgrade modulus along uh, y direction, only y direction assigned, and also we have to assign z direction and x direction. The subgrade modulus of x direction and z direction will be the 50% of y direction. So is y direction subgrade modulus reaction how much? 2133 and 2133 2133, and x direction and z direction will be 50% of it. So into zero point 0.5 is equal to 1066.5 means 1067. So this and that subgate reaction we will provide uh, to go to the common file and save is now support, and this is the subgate reaction which are provided along y direction. Now it will be the x direction also and z direction also of 50% of y direction. So now this is copy, copy and paste. This is y direction and z direction. Here z direction, and this is the 50% means 1067, and also paste, and this is the x direction and it will should be 1067. Now the subgate reaction along three direction are completed. Property also assigned, so it will say yes. Now analyze or analyze. It will take some time to analyze the foundation. Now zero errors and one warning. It is mandatory to uh, come say one error. So view file, maximize. This is the multiple support command. So don't worry. It will no problem and neither create any problem to your structure. And there, this is the response. Static response is greater than the dynamic base share. So we have to scale up this scaling, this factor, time period for x along x direction. So this is 2.1554, and note this 2.1 2.1554 and x direction and z direction same. So now this is, and go to command file, and here 2.1554 2.1554 2.1554. Actually something increasing it 5 5 5 5 5 5 1.1595. Run. 6 notes. One warning. So up to this is the 1.1 along Z direction. Means 1.101 times greater than the uh, static base here. So this is the iterative command file. Now Z direction is mm, 2.1555 into 1.101 is equal to 2.37. So we provide 2.38, 2.38, 2.38, 2.38. And this is the greater between x and z, so which is provided in y direction. 38, 38, and this is x direction, and this is z direction. 38. Yes. Again, analysis. General analysis. You can design and create model like this to any structure. That means the structure uh, G plus 6, G plus 7, 10 in a structure you have to provide. So now this is the 4 nodes. So now base here problem is fixed. So the structure is ready to design. Now concrete. Yeah, type 6 and clear point 50 mm means 0.5 mm and ends 1 ends 1 for the warning uh, depth to length ratio. Depth C is into 5,000 that FY is 500,000. FY sec on 15,000, max 25 mm, secondary 12, and the history of 10 and 8, and terrains 1. Okay, so now close all the assigned to group. All the parameters are assigned to group. So it could be command design beam and design slab. Check off. Okay. Design beam means I'm talking about this beam, actually grade beam. Assign, and element assigned to view. Yes. Now again run. Say 324 errors, which is what is the error? Section fail, beam section fail, resistant element. So we have to increase um, 0.5 meter. So this is the problem. And go to command file and design. Actually, it is here problem means here 50 means 0.05. So close. Okay. Analyze. Now zero errors. So all the beams and actually plate are passing, and this is bottom 505.75 square millimeter bottom reinforcement of beam, uh, top reinforcement minimum reinforcement 7 was actually 10 diameter, and this is the beam and slab. This is the slab. So 534 cent, and we can also check the bending moment and surface before that we have select that beam view check, and we go to post processing. Yeah, and this is the MZ reflection bending moment beam results. Now the diagram is very small, so go to view label and scale bending moment z direction, actually 20, apply. Now you can see the bending moment diagram of all the grade beam. and you can decide which beam is mostly loaded. You can see, and you have to mind it firstly that the Raft slab, which should not cross the brace pressure, means actually I am to say the pressure according to the structural load, due to structural load, the pressure beneath the foundation is should not greater than the gross bearing pressure. I mean, if if the if the shape bearing capacity if the shape bearing capacity if the shape bearing capacity is 8 ton, means 80 kilonewton, and plus, and your foundation depth is uh, 2 meter and 2 meter 2 meter 2 meter, and the unit weight of soil is 18 kn per mq. So the weight of soil is uh, 2 2 into 2 into 18, actually 36 kn per meter square, the pressure of that soil. So the gross pressure will be 36 plus 80 is equal to 116 kN per meter square. And this value, your base pressure should be within this value. If the, the base pressure is greater than this value, then the structure is settled down and structure is collapsed. So it should be minded that the bearing pressure always should be lesser than this gross bearing pressure, which is taken from the geotechnical report or soil investigation report. So, how to check it? You have to post processing result and plate result, and to go to the load, uh, dead load and live load means 111, and here the brace pressure applied, and now your brace pressure is maximum 72.7 kN per meter square, but as per your geotechnical report, the gross pressure is 116 kN per meter square, so the structure is absolutely safe. You can design like this any structure by forming this modeling, and you can see clearly the maximum pressure in the middle due to this structure, because the structure is symmetric structure, and all the panel and all the actually section is same. So, and load also, all the members are actually symmetric and same. So uh, in this case, the maximum pressure of foundation is in the middle, 20%. So this is the your complete video for how to design a mat foundation with grade beam.